Hello everyone, this is Katie. Today's topic is function notations. Function notations is to represent a function such as linear, quadratic, cubic, rational, and list goes on. So we usually use the notation like this, and we read it as f of x. The linear ones are like y is 2x plus 3, quadratic, cubic, and rational. These are the examples of functions. The value of x in the bracket there, this represents input value to your equation. For example, you're given with f of x is equal to 3x squared minus 2x. Then what would be the value of f of 3? So how do we do this? Whatever value you have inside this bracket after the function notation, whatever the value inside the bracket, it will replace all the x values in your equation. This 3 will replace all the x value in the equation, given equation. So we've got x over here and x over there. So we're going to replace all the x with 3, like this. And then you just need to computate the equation on the right side. So that will be the value of f of x when the x is equal to 3. Okay, let's try another example. We've got f of x is equal to square root of 2x squared plus 8x. And also we have another equation, another function. I'm going to call that g of x. And that is defined as 2 over x plus 3. The question is to find f of 3, g of negative 4, f of 4, g of 3, plus g of 4. So let's find all these values. So let's start with the f of 3. We're replacing all the x with the 3. So these are the x values. So that will be square root of 2 times 3 squared plus 8 times 3, square root of 2 times 9, that is 18, plus 24, that's square root of 42, and that cannot be reduced, so we'll leave that as that. That's the answer for f of 3. Let's do the same thing for g of x. Here, the function g of x, the input is negative 4, and we're going to replace the x in that g of x with the negative 4. So 2 over negative 4 plus 3, that's 2 over negative 1, that's negative 2. Next one, f of 4, input is 4, square root of 2 times 4 squared plus 8 times 4, 2 times 4 squared, that's 16, so that will be 32. 4 times 8 times 4 is 32, square root of 64, which is reduced as 8. Last one, g of 3 plus g of 4, okay? So this one, people might think this is maybe g of 3 plus 4. Is that true? We're going to check that by doing this, g of 3 plus g of 4, and then we're going to try see if it is true for g of 3 plus 4 is same as g of 3 plus g of 4. Okay, so let's try that. So what's g of 3? That's 2 over 3 plus 3, which is 2 over 6. G of 4 is 2 over 4 plus 3. That's 2 over 7. So g of 3 plus g of 4 is 2 over 6. Or let's reduce that as 1 over 3. 1 over 3 plus 2 over 7, which is 21. If you're using the common denominator, which is 21, that will be 7 and 6. So that will be 13 over 21. So that's what we got. And let's check to see if it is true for g of 3 plus 4. So g of 3 plus 4, that is g of 7. But if you plug that into the g of x, 2 over 7 plus 3, which is 2 over 10, which is not same as our answer. So to remind you guys, whenever you see g of the addition of functions, make sure you find each value separately and then add that later, because this is not obviously this is not gonna give you this the same answer or right answer. So just be careful not to do this to get the answer. So this is not what we want. So make sure you do follow this way to get the answer. Next, so far in the previous examples, we only had the integer, or we actually used the numerical values for input for functions. Now we're going to use the input as a function. So here's the title. So input, what happens when the input of the function is actually a function or expression? Input as a function. So same rule will apply. So we're going to replace every x in the equation with the same input function. So we're going to use the example. So let's say you have f of x is 3x minus 4, and another one, g of x, is 2 minus x over 3 plus x. So the question is, what would be the output when you have g of f of x? So here the outside function is the actual function that we're using, and the inside the bracket next to the g, that is the input that we're looking at. So this is the input, and the outside is the function that we're going to take. So g of x is this. So we're going to replace all the x in the g of x with the f of x. So if we rewrite that, that will be 2 minus f of x over 3 plus x. Like that. Oh, going back. No, we're supposed to replace the x with the f of x. So this should be f of x. Okay. Once you have that, we're going to replace the f of x with the actual expression for f of x, which is 3x minus 4. So since we're using subtraction in the numerator, make sure you have a bracket after subtraction sign here. So this is 2 minus bracket 3x minus 4. The reason we are putting the bracket around the 3x minus 4 is you have to distribute the negative or the subtraction sign inside the bracket to simplify in the next steps. And then 3 plus 3x minus 4. For addition side in the denominator, we don't need to put the brackets, but I'm just using the bracket to make it even, or make it more clear that we're replacing the f of x with the 3x minus 4. Okay, once you have that, let's distribute this negative sign, subtraction side, into the brackets. So that will be 2 minus 3x plus 4 over 3 plus 3x minus 4. Let's simplify, and that will be negative 3x plus 6, 3x minus 1. And that is our answer for g of f of x. Okay, maybe let's try finding the f of g of x instead this time. So we flip the order of the functions. Now the g of x is the input. and the f of x is the outside function. So we're using the f of x as the form, and then we're replacing the x in the f of x with the g of x. So whenever you see x in the f of x, we're going to replace that x with the g of x. So this is the x in the f of x. So 3, and 3x means 3 times x. So 3, and maybe we can put the bracket like this to represent that as the multiplication, and then minus 4. G of x is this one, a fraction, so 3 times 2 minus x over 3 plus x minus 4. Let's multiply that 3 in the numerator, so distribute that into the numerator part. So that will be 6 minus 3x over 3 plus x minus 4. Let's combine these together into one fraction. So that will be 6 minus 3x over 3 plus x minus. So having the denominator the same, we can combine these two fractions. It will be 6 minus 3x minus 4 times 3 plus x over 3 plus x. Simplify by distributing this into the brackets. 6 minus 3x minus 12 minus 4x over 3 plus x. Combine the like terms, negative 7x minus 6 over 3 plus x. And that is the answer for f of g of x. Let's try a few more examples before we finish. Given the f of x, 2 over 3x plus 6, g of x, 3x squared minus 2. Let's find g of f of x, f of g of x, and maybe f of x. Okay, so once again, f of x is inside the brackets, so that's the input. And we're going to replace x in the g of x. So this is the x that we're going to replace with the f of x. So it will be 3 times f of x squared minus 2. So make sure you put the same exponent after the f of x. 3 times, I'm going to replace the f of x with the 2 over 3x plus 6. So this will be replaced with this expression. Minus 2, and squared. So 3 times 4 over 9x squared plus, if you square that expression, it will be 2 times the multiplication of these two the numbers. So that will be 4 times 2, 8x plus 36 minus 2. So distribute 3 into all the terms inside the brackets. So that would be 4 over 3x squared plus 24x plus 108 minus 2. So the answer is 4 over 3x squared plus 24x plus 106. And that is the value for g of f of x. Let's try the f of g of x this time. So this time the input is g of x. And we're going to replace the g of x into the f of x. This is where we're replacing this time. 2 over 3 times g of x plus 6. 2 over 3 times 3x squared minus 2 plus 6. Distribute inside the brackets. That will be 2x squared minus 4 over 3 plus 6, 2x squared. We multiply, add these two, so that's 18 over 3, so that would be plus 14 over 3. And that's the answer for the second one. Okay, the last one, let's try finding f of x. So we're inputting f of x into f of f function. So maybe we can rewrite f of x on this side. The given function is 2 over 3x plus 6. So this will be 2 over 3 times f of x plus 6. Basically, we're replacing the x with the f of x. And then replacing f of x here with the expression, which is 2 over 3x plus 6. 2 over 3 times 2 over 3x plus 6 plus 6. Distribute the 2 over 3, 4 over 9x plus 4 plus 6, 4 over 9x plus 10. And that is the answer. Okay, so these are the examples that I have for function notations. So thanks for watching, and I hope to see you next time.